World's tallest mountain. Mount Everest draws hundreds of climbers each spring, with adventurers paying tens of thousands of dollars and risking their lives in the death zone above 26,000 feet. But here's the thing that's going to blow your mind. They're not actually climbing the tallest mountain on Earth. The real giant is Mauna Kea, a dormant volcano sitting in Hawaii. When you measure from its true base to its summit, Mauna Kea stretches an incredible 33,474 feet into the sky. That makes Everest's 29,032 feet look pretty ordinary by comparison. We're talking about a mountain that's more than 4,400 feet taller than the supposed king of peaks. The reason nobody talks about this is simple. Most of Mauna Kea hides underwater. The volcano rises from the ocean floor, with only 13,796 feet visible above sea level. New 2025 oceanographic surveys using advanced sonar mapping have confirmed these underwater measurements with unprecedented accuracy. So while thousands of climbers continue risking everything to reach Everest's summit, they're actually scaling a mountain that doesn't even hold the height record. But if Everest isn't the tallest mountain, surely it must at least reach closer to outer space than any other peak on our planet. Earth's closest point to space. Wrong again. Since Everest stands taller than any other mountain above sea level, logic tells us it must reach closest to outer space. After all, height equals proximity to the cosmos, right? Well, our planet has other plans. Earth isn't the perfect sphere you see in textbook diagrams. Our planet's radius measures about 6,378 kilometers at the equator compared to 6,357 kilometers at the poles. The physics behind this involves Earth's rotation creating centrifugal force that pushes mass outward at the equator. So which mountain actually extends as the farthest point from Earth's center? The answer takes us to Ecuador, where Mount Chimborazo rises from the Andes. This ancient volcano doesn't come close to Everest's elevation above sea level, reaching only 20,564 feet compared to Everest's 29,032 feet. But here's where geography gets interesting. Because Earth bulges at the equator, Chimborazo's summit extends further from the center than Everest's, even though it is lower above sea level. The latest 2025 satellite measurements using GPS and laser altimetry show that Chimborazo's peak extends 6,384 feet further from Earth's center than Everest's summit. Your location on the planet matters more than your altitude when you're trying to reach for the stars. Speaking of location, let's talk about how badly we misunderstand where entire continents actually sit on our planet. Africa's hemispheric location. Picture Africa on a world map. Where do you see the equator cutting through the continent? Most people imagine it slicing somewhere near the top, making Africa primarily a southern hemisphere landmass. This mental image shapes how we think about African weather, seasons, and agriculture. Close your eyes and try to visualize exactly where that equatorial line crosses Africa. Got your mental picture ready? Now prepare to have it completely flipped upside down. The 2025 Continental analysis reveals that almost two-thirds of Africa actually sits north of the equator. That means the majority of this massive continent experiences northern hemisphere seasons, weather patterns, and agricultural cycles. Consider Cairo, Egypt with its 20 million residents living firmly in the northern hemisphere. Even Nigeria's Lagos, home to 15 million people, lies above the equatorial line. This geographical reality explains why northern African countries have different seasonal patterns and climate zones than many people expect. This misconception about Africa's hemispheric position leads people to misunderstand the continent's climate diversity, agricultural potential, and seasonal patterns across 54 different nations. The truth is that our mental maps of entire continents can be completely wrong, and these mistakes extend far beyond just land masses. Sometimes we get confused about the very names of countries themselves. Britain's political geography. Walk up to someone on the street and ask them what country the Union Jack represents. 9 times out of 10, they'll confidently answer, Great Britain. This mix-up happens so often that even news anchors get it wrong on international television. The Union Jack actually represents the United Kingdom, not Great Britain. These aren't just different names for the same place. They describe completely different things. The UK is a sovereign state of 4 nations, but Great Britain is only the main island. Great Britain is simply the name of the largest island in the British Isles. This island contains England, Scotland, and Wales, but leaves out Northern Ireland entirely. So when you say Great Britain, you're talking about geography, not politics. The United Kingdom includes that same island plus Northern Ireland, making it the complete political entity. This confusion creates real problems in international settings. Getting this terminology wrong in diplomatic situations can actually offend people from Northern Ireland, who might feel excluded when someone uses Great Britain to describe their country. Geographic misconceptions don't stop with political boundaries. Some of the most famous landmarks on Earth come with their own set of persistent myths that have fooled people for generations. The Great Wall's space visibility. Here's one of the most persistent myths in geography. You can see the Great Wall of China from the moon. This claim has survived for nearly a century, appearing first in a 1932 Ripley's Believe It or Not cartoon. That's right. This myth existed decades before humans ever left Earth's atmosphere. What do astronauts actually report seeing when they orbit our planet? The answer might surprise you. Crew members from the International Space Station consistently state that the Great Wall is nearly impossible to spot with the naked eye. The 2025 photographic evidence from the ISS confirms what space travelers have been saying for years. The wall simply blends into the surrounding landscape. The technical reasons are straightforward. The Great Wall was built using earth, stone, and brick materials that match the natural colors of the terrain. From space, these construction materials create no visual contrast with the surrounding environment. The wall's width, typically around 15 to 25 feet, is far too narrow to register as a distinct feature from orbital altitude. Meanwhile, modern highways with their dark asphalt surfaces and large airports with concrete runways show up clearly in space photography. These structures create sharp contrasts against natural landscapes, making them far more visible than China's ancient wall. But space isn't the only place where our eyes can deceive us about size and scale. Greenland's deceptive size. Look at any world map hanging in a classroom, and Greenland dominates the top portion like a massive green continent. The island appears so enormous that many people assume it rivals Africa in size. This visual impression has fooled geography students for generations. But how big is Greenland compared to other landmasses you actually know? The answer reveals one of cartography's most deceptive tricks. The Mercator projection, created in 1569 for ship navigation, accurately shows shapes and directions, but completely warps the size of anything near the poles. Updated 2025 analysis of projection distortions shows just how dramatic this warping becomes. The Mercator system stretches areas at higher latitudes, making northern regions appear vastly larger than they actually are. This mathematical distortion affects how millions of students perceive global geography. Greenland's true area measures 836,330 square miles. That makes it smaller than the Democratic Republic of Congo, which spans 905,355 square miles. When you see these landmasses displayed using accurate equal area projections, Greenland shrinks dramatically while Congo maintains its actual size. Side-by-side comparisons using modern mapping software reveal the shocking difference. What appears as a continent-sized landmass on classroom maps is actually just the world's largest island. These projection distortions extend beyond individual countries to affect how we understand entire continents themselves. Australia's continental status. Ask anyone to name the smallest continent, and they'll confidently say Australia. This seems obvious when you look at traditional maps showing Australia as a lonely landmass surrounded by ocean. But what actually defines a continent in the first place? The answer isn't as simple as measuring land area. Continental definitions involve complex geological structures, tectonic plates, and continental shelves that extend far beyond visible shorelines. The traditional seven-continent model taught in schools is largely a cultural construct, not a scientific classification based purely on geological criteria. Here's the shocking truth from 2025 landmass measurements. Europe is actually smaller than Australia. Europe measures approximately 10.18 million square kilometers, while Australia spans 7.69 million square kilometers. The confusion comes from how we define continental boundaries, which often follow cultural and political lines rather than geological ones. But the real eye-opener involves Australia-Oceania as a complete continental system. This broader definition includes New Zealand, Papua New Guinea, and thousands of Pacific islands scattered across millions of square kilometers of ocean. The continental shelf connecting these landmasses creates a massive geological unit that dwarfs most other continents. When geologists examine tectonic plates and continental crust, Australia-Oceania becomes a giant that simply appears small on surface maps. Our misconceptions about size don't stop with continents. Sometimes the most famous examples of entire geographical categories aren't what they seem.